Now, the group I have not mentioned are the proteins. Proteins have a rapid rate of breakdown by the soil microbes, yet their composition in the humus, the semi-stable portion of the organic matter in the soil, is much higher than it typically would be in the material that's being added, the fresh plant residue. Well, if we think about this for a minute, what could possibly explain that? It's rapidly mineralized or broken down, yet it builds up. Well, the only real logical explanation here is that proteins that are being broken down must be remanufactured or resynthesized into the humus portion of the soil. And indeed, that is what happens. Proteins will build up in the humus portion of the soil due to the very high content of protein in the microorganisms themselves. And we need to understand that the humus not only contains the highly re-altered and resynthesized organic components that were a part of the original fresh plant residue, but it also contains all of the living and or the dead and decomposing microorganisms that are breaking this material down. And for that reason, we see a very dramatic increase in the protein content of humus as compared to the fresh plant residue that's being added. Now, from a practical standpoint, how might we use that information? Well, we use that information a couple of ways. One way is it helps us to understand why the organic matter component of the soil is a major reserve source for nitrogen, phosphorus, sulfur, and some of these other macronutrients that plants use in fairly high quantities from the soil. If these microorganisms are remanufacturing additional proteins and then they are a part of that humus, this humus portion becomes like a reserve supply of those nutrients. And in fact, the major reserve supply of nitrogen, and in many soils also phosphorus and sulfur, is found in the organic fraction of the soil, not necessarily in the mineral fraction. That holds true the vast majority of the time with nitrogen, but it also holds true quite often for sulfur and maybe to a lesser extent phosphorus, but it can also be very much true for phosphorus as well. The other utilization we can make of that information, the fact that proteins build up in that humus portion of the soil, is that it explains to us why, as we manage the soil, we need to be very conscious of where that organic matter content is in our soil, and we need to do what we can to ensure that we are maintaining, and when possible, even increasing the organic matter content of a soil if that soil had been poorly managed, as an example, and contained a lower organic matter content than what it should. One thing we do need to keep in mind, though, and that is that we are not going to appreciably change the organic matter content of a soil over a long period of time unless we do something fairly dramatic, because that is determined primarily by the climate and the amount and type of vegetation that is prevalent in that particular area where that soil has developed. Now, many of the things we do from a cultivated agricultural standpoint have a tendency to cause that soil to decrease slightly in organic material in comparison to if that particular location were left in a solid stand of, say, perennial native grasses, which would be typical in much of the region that we're located in here in the Pacific Northwest. Much of our soils initially prior to cultivation here in this area as well as others in the Pacific Northwest were, if not under forest vegetation, then they were underneath a grassland vegetation. And being underneath this grassland vegetation, they were quite high in organic material, especially if we had enough rainfall to where we had a substantial amount of vegetation. Upon cultivation, the initial effect is that these soils will decrease in organic matter content. And even if we're doing a good job of conserving the soil and preventing erosion and returning residues to the soil, many of the things we do in cultivated agriculture will have an initial effect of causing a decline in the organic matter content of the soil. We'll decline slightly, we'll reach a new equilibrium level of soil organic matter, and then if we stay in a similar management system, returning residues approximately the same amount in type periodically, our organic matter content should restabilize. However, it will be at a level slightly below that which was present under native vegetation.